Good morning, I'm Roberto Novonisi from Laser Navigation. In this video, we introduce you to our SophyAI platform and its latest developments in the field of robotics, in managing infrastructures, and with the perspective of creating AI agent. It's a platform that has already received several awards at various levels, both in robotics and in infrastructure management. We have achieved in these years
several patents.
Specifically, in 2018, we applied for our main patent, which is that of management and control of a process through artificial intelligence techniques. And this is somewhat the patent on which all the technology is based, which we will present to you today. From the perspective of applications, we have developed solutions in the field of autonomous robotics management,
of infrastructure and data, a massive collection of songs. Yes, I am on it.
In particular, in the field of robotics, we have developed several robots, applications especially of vision, supervision of confined spaces such as tunnels and strategic infrastructures.
We have also in the past,
I have also worked extensively on flying drones and then more recently on marine drones. All our SophyAI technology we've applied in this context, we're creating a digital tool. Understanding the context is crucial for this reason.
For the assisted automatic operation.
Specialized staff. The beginning of robotics development within our company. It launched in 2008. I am one of the founders of ArduPilot. It's an open source goal that several systems rely on today.
Sit me down.
Professional that is advanced in the field of research and development. In 2014, we worked a lot on miniaturization. We continue to work a lot on that. In 2015 to 2016, we began accordingly the evolution of robotic systems integrating artificial intelligence up to us to this day, where we have then integrated what is our key platform, which is SophyAI. These are some use cases we've worked on in the past. One of the most interesting is precisely was what we also have the patent for, and with which we have previously collaborated with a startup called Arke for the realization of autonomous drones capable of landing and taking off autonomously from a platform, charging, essentially carrying out its missions and then returning to the point as a starting point ready for the year. You have a lot. Definitely Axel. Axel is a robot that was commissioned to us by a research project developed with CIM4P.
And with Reply.
Basically, he gave me the chance to study based on a platform of Merlo, which the is the self-builder of vehicles. In the industrial field, we have included everything related to navigation, teleoperation, and collision avoidance during activities. Movement of the vehicle.
Of the small
this is an example.
Theater. Precisely in a gallery of the gallery.
Operators with as in Talsvikon, with a ground station were able to control the high-speed train. During the design phases, we focused a lot on reliability and control, even in very complex scenarios that replicated a bit of those scenarios available within For Glory. Yet another image where we can see the ground station and the operators who they also monitor all the environmental parameters inside the tunnel before letting staff in. This is another robot developed in this case for kerosene start rocket Ciceni, to carry out periodic inspections of the Favasina gallery that leads electricity from the top of the mountain to the beach. Especially, this is a very complex since the electromagnetic field has a very strong field generated by the electrical triads. Our robot, besides being teleoperable, conducts its inspections with thermal cameras in the visible spectrum. And had environmental sensors. It also has a shield that protects it from electromagnetic emissions. This is the next one. Another screenshot of this robot we made. You can see the antenna, the control antenna, and the inspection camera, the thermal camera. The tools in this case are singled out. Other screenshots and others perspectives, such as integrating the rover into the tunnel. In this case, the rover the rover also has lights that illuminate its path, and it can operate by following this track. This is another robot we made for more agricultural applications, always remotely operated, always autonomous, that can be used for environmental inspections. This is a sensor that was specifically made for conducting specific soil quality surveys. In addition to robots, we have also extensively developed custom command consoles or ground stations. Somehow they went to solving user experience issues. In the robotics field, as I was saying, besides aerial and terrestrial robotics, we have worked on the creation of marine drones. In particular, we've created a robodinghy, a dinghy equipped with artificial intelligence and a remote piloting teleoperation system, was created for experimental activities in a context, environmental or support checks for certain activities like those of it's just an experimental project we've been working on for a while. On Ingy's robot, we have installed some techniques, advanced LiDAR systems or systems of underwater inspection, allowing us to implement various types of services. For instance, bathymetry spot checks, or through the use of side scanner, also 5 analysis. Here is a video of a side scan sensor connected aboard the Ingy robot, allows us to scan right away. We are also currently developing a version that can go as deep as about 250 meters to observe relics more closely.
Or situations in which
we just managed to take action to perform some operations. What's interesting is that images from side scanners can also be analyzed by specialized artificial intelligence systems in such a way that you can already reference the various objects presented, recognized more closely by artificial intelligence, possibly later with ROVs.
Another product being made for the marine environment is the IVRB.
What's up? Based on our Voyager Captain autopilot, and its connected mouth through 4G and 5G routers to a control system that coordinates their movement in swarm mode with the other buoys that make up the field. Rest of a sailing regatta. The application can be one that works both in the cloud and on soft devices. All those experimental projects were developed within our field test on Lake Zeo. The field test is located around Monte Sola Island. Essentially, we have about 30 kilometers of path around the island available for our experiments. And besides conducting experiments on the surface, so sailing both by sail and by stone, even with electric means, and in the future also with the foiling systems, we will be able to cover 200 or 300 kilometers of track in a day. Experimental journey. Moreover, this area is also suitable for underwater experiments. Indeed, the depth is 270 meters, which is a depth sufficient for experimentation, rather complex. These conditions are hard to find in marine areas so close to the coast. After the experience in robotics over the last years, we realized how robots in complex scenarios such as a dam or a power plant or even an industrial plant, when it moves within these infrastructures, it faces the issue that its sensors have limits, restrictions. Volumetric analysis cannot go beyond to analyze the areas of a plant where he will have to go and will have to, for instance, moving, let's say, over infrastructures or people. So what we realized is that the robot alone does not have the ability to perceive the entire environment in which it will have to move. And from here came the idea of SophyAI, understood as digital twin, able to start from images of a real scene, reconstructing a real-time 3D model of the environment that somehow allowed robots, but also possibly first response teams to take action inside the plant and that infrastructure. From this idea, which developed in 2018, we have made first a deposit of an Italian patent. This patent was recognized in 2020, and then in September 2023, the European patent was also recognized. We are still waiting for the American patent, which allows us to continue developing this technology with peace of mind in its various facets and specializations with awareness. What we have achieved so far is extremely innovative. Now we introduce the project and the idea and explain it a bit more in detail.
I could
Everything
do that.
in view. System architecture. SophyAI is capable of creating a real-time digital twin. How is this digital twin created? It's made using sensors already present in the scene, perhaps pre-existing, used only for video surveillance before. But today they can be used as sensors to detect, recognize objects or people or things in the scene, geolocate them precisely, and bring them back into a map. This allows us to create this digital twin with a frequency of about 1 unique update, 10 updates per second using sensors that can be ordinary cameras. These can be thermal cameras, LiDARs, or even the radars. Once the 3D scenario is created, where all objects are classified and located, and you can see them moving within the scene, we can define rules for that area with a workflow system for that scene, and make sure that if these rules are violated by the operators, the vehicles, the robots that move within the scene, the system can generate alarms and take countermeasures to what is happening at that moment. This is somewhat of a novelty, which has, let's say, fields and of applications very extensive in very different fields. In fact, soon we will see several complex in different areas, from smart cities to smart roads and other applications also in the marine field. Here's here's how we were saying. We can manage different types of sensors. These heterogeneous sensors among themselves, they can also provide an advantage from the standpoint of detection algorithms, because maybe what an IP camera can detect at night, a thermal camera can. Thermal camera or a LiDAR, or even a radar. This data placed in a scenario unique. They let you see it from multiple viewpoints, hence going to confirm, for example, the presence of a vehicle, a person possibly in a field, nighttime, which with only one of these sensors, maybe at certain times in certain environmental conditions, is not possible to validate. Our system can interface with IoT devices, as we mentioned, both from a sense perspective and an activation perspective. So the artificial intelligence, SophyAI, can interact with the real world through the IoT systems already in place. Can open a boat, can detect smoke, can detect environmental parameters, as in some of the projects.
Things we made in the field of smart building.
Moreover, it can also transmit information to robots, terrestrial or flying, to ensure they can intervene in real time in a complex scenario, and to go and check up close what is actually happening. We have also made implementations and experiments at the level of satellite systems. Something happens and the radars warn me of something that has happened. I can activate a satellite to go to see detailed photos of that area and to carry out a further analysis and scans. Over time, we have worked on different types of algorithms. These algorithms we have
implemented
algorithms ranging from
at the rise of man down to
stay clear-minded
traffic,
but also in calculating the volume, in an area of collection of materials from outdoor warehouses, or also identifying any breakages, pancakes found on the infrastructure. What kind of detection of fire, especially on the topic of fires.
We developed a patrol.
Special attention and specific technologies, thanks. Let's also mention one of our engineers, Marco Preziosi, who has filed this detailed study on the behavior of artificial intelligence networks in the field of fire detection testing.
With different scenarios.
And to check the effectiveness and efficiency of these networks. GameQuest. At the moment, thanks to technological advancement, they prove to be extremely effective. For instance, this is one of the continuously evolving algorithms that our platform can handle, and you can use it to better understand what's happening inside the scene. We then implemented mobile systems in this notion. Indeed, from an experimentation perspective, we found the need to verify with our customers the different behaviors of various sensors in different scenarios, especially from a perspective of anonymization. We have observed a night division. That radars too can work very well within our SophyAI platform. Moreover, we can mix both radar and cameras to monitor progress, human growth of a construction site, but also to check the behavior people in the middle of the construction site to prevent potential issues, to staff working within these programs of these infrastructures. The system is equipped with multiple heterogeneous sensors among themselves, and this allows us to have more confirmations, for example, of a behavior of a scene that is happening within a society, infrastructure. This is a very important topic in strategic contexts, like the smart road, where the importance of multiple checks to validate a situation is definitely important. Our goal is to create an artificial intelligence system that monitors a scenario 24 hours a day, per day, 365 days a year, creating a risk management dashboard to always keep risk within acceptable safety parameters for the company. Worker safety. We can check for violations of with rules and processes. We can check for any illnesses, staff issues, or realize count of incidents through smoke sensors, fire, or even sound, or unauthorized access or intrusion by people into unauthorized areas in the field of smart load. Here too we have carried out various research and development activities and also consolidated technologies. Significant tasks, both in terms of vehicle classification and the management of emergency and protection measures with a view to preventing collisions in areas within construction sites, rather than man-down checks, file detection, and intrusion detection always within facilities. Important roads. There is no lead. Vacuna. In the marine field, we developed SophyAI Marine Sentinel, a platform capable of keeping a ship's bridge under control, ensure that workers performing tasks are in safe conditions and do not have problems during their work. Specific loading and unloading of docks during navigation activities. And also with our system, we're able to provide a maritime collision avoidance system, efficient, that can use both ADA and cameras and radar and sensors even in the field, in the air field, specifically to provide the highest level of safety to drones, because initially this technology was developed for our autonomous drones regarding vessels with crew on board. This technology has the advantage of also being able to detect some vessels that might not be equipped with RF signaling systems, V-tracker, and so on. This is a bit of the object, one of the objects we have built. The advantage of our solution is that on one hand, it can reuse much of what's already installed in many infrastructures like cameras or LiDAR or IoT systems. Where the sensors are not available, we can integrate them, so we can actually retrofit the infrastructure with a low cost for introducing AI. We analyze data flows that are already inside of the infrastructure itself. Our system is modular and is scalable, support architectures both in cloud, where we send the sensors to the cloud and analyze them there, or for privacy reasons, we can also analyze the sensors in edge mode or entirely on premise, kind of like what we do with our drones when they autonomously navigate through the sea. Let's say we've brought some robotics into the infrastructure. That's a bit of our vision. The advantage of our company is that it has a very important skin in the field of creating custom neural networks capable of object detection of custom objects. We can allow our client to create conditional workflows of visual languages within which to define rules and opera. We also have a development underway this very year of a new workflow generation technology based on generative neural networks, LLM, which we will talk about later. This will allow us to have an even more flexible system from this particular point of view, and of workflows that control digital twins produced by our AI platform. Last but not least, these technologies are rapidly evolving, and our platform does continuously evolution. Thank you. In the next session, we'll analyze with
use case that we have implemented in recent years, where we have used our technology. with this brief introduction,
we show you some of the use cases we have implemented in recent years. These use cases are part of the experimental activities carried out, but let's say they are the more meaningful and heterogeneous ones among them. One of the most interesting applications where is definitely the one of anti-collision. We have developed systems anti-collision mobile construction sites and road vehicles, this in a perspective of implementing smart road logics to increase road safety. We had conducted several experiments and developments specifically in the economic field, not even by a long shot, specifically in the recognition and real-time detection of vehicles and others, lane inversions that are protected as operators are working inside them. We then developed another interesting use case with the Politecnico di Milano, where we implemented a system for monitoring people's presence in various rooms. But the other, in its latest revision, also implemented a logic of integration of IoT sensors to monitor the CO2 levels in different rooms specifically at their employment level. That's it. Bye. Even on a decidedly fascinating. So the use of artificial intelligence and the use of the Internet of Things, though the comparative data analysis leads, let's say, to obtain a whole series of information that IoTs alone did not allow to obtain. So the number of people occupying listed, we then implemented control systems for plants to see access to various areas, check access security to various areas, the parking area, the loading, unloading area, and also systems of automation and the integration for gate opening or activation of systems within industrial plants. In this case too, another industrial facility where we control vehicle access and traffic flow. In this case, we also have a theme from area text to be monitored to prevent vehicles loaded with the material. Flammable materials cannot park near critical areas. We have both an AI solution and a solution with a smartphone, so the systems interact with each other and allow you integrated localization, both people with smartphones who collaborate and those who do not collaborate that may be present in the other. Just a comparison between collaborative and non-collaborative ones allows us to highlight those that can be of unauthorized intrusions in some areas of the commitment, crying in this case also within a client's facility. We have implemented control logics of Manda. This is a cryobank.
We're trying to interact.
There's are gases in the area of the legs, which have a smell that can lead the operation
The actor to faint, and in case
from the most critical to death due to oxygen deficiency. The system can detect these issues, generate alarms, and automatically activate ventilation systems to restore the oxygen level inside and in the area to normal levels, then alerting the emergency teams in full.
right? It'll be kind of
Biggest
structure yet. Another system we
as
have
implemented instead both forklift and people anti-collision inside facilities here. We have a whole series of projects with various customers on collision avoidance between vehicles and people, and this too is a very, very hot topic where artificial intelligence can help a lot. there is a strong need for network training because in complex environments, many networks, they are not available, so they must be trained from scratch. It incurs quite significant implementation costs. We have gained experiences of training directed in various scenarios, and this allows us to be quite flexible in improving
library reality detection.
This, however, is another facility we've built for the multiport. In this case, our artificial intelligence system installed through cameras at the embarkation ports, it can check the amount of vehicles, classifying them by means of transport, heavy, light motorcycles and whatever else, and identifying possible waiting times to be boarded on the ferry, essentially. This is a solution that the Ministry of the Gozo has adopted,
and then just for control access to its ports.
In this case, however, we have developed and tested systems.
The systems
sono tracking and control of behavior within infrastructure such as tunnels. This is also a project
gets lost,
which allowed us to gain experience in this field. Another project that also won us an award with Bosch was a project of the parking is wanted. In this case, the project was done in a period where artificial intelligence was only recently applied in the field of parking, showing significant potential compared to the more traditional techniques of image processing. So image processing is slower and less precise. Artificial intelligence can be much more accurate and much faster at detection of cars, of vehicles, of people. This allows for the implementation of much more efficient algorithms to create smart parking solutions. We then worked on has projects with NLEC for crack recognition on infrastructure for the L'Aquila reconstruction project, where we also experimented with 5G transmission from drones of these images to a control center that then analyzed data collected and could somehow identifying infrastructure criticality as detected by AI. From drone data, here, let's say, these use cases are some of the most interesting use cases, and now that we will instead go to see a new solution related to on the topic of generative artificial intelligence applied to workflows.
Besides creating digital twin using techniques
of artificial intelligence, as we had discussed in previous presentations,
one of the major topics
is precisely that of creating efficient workflows
to be able to identify,
apply the rules to these digital twins to generate alarms or manage situations, extremely critical situations in these scenarios. From here, a path of analysis began
almost a year and a half
on generative AI, specifically language analysis. This kind of analysis led us to create a strong and significant background in the knowledge of these trainings. AI LLM algorithms with the aim of tackling complex topics, making the most of it. All the documentary heritage that a company may already have at its disposal, and that can be used to extract what may be possible. the rules to be followed within certain scenarios and certain opponents environments. This journey, which initially was only about creating more effective dynamic workflows, actually evolved, and it has led us to build an extremely interesting architecture that can be applied not just on digital twin, but also on all documentation aspects and needs that go a bit beyond infrastructure aspects and robotic management. They are all related algorithms anyway. Our platforms are interconnected and allow managing both vision and management algorithms. About LLM as well. This year's latest revision of our platform. Have a pleasant evening.
Our generative artificial intelligence system based on LLM techniques, it's essentially thought to have an architecture flexible interfaced with IoT systems. In fact, our system is able to connect to MQTT brokers, for example.
Coughing up that through the API to information systems or via scraping as well, CityWeb or the customer document repositories that contain a variety of information. These details may change over time and thus are not static detailed. So kuolema suostamas baka dormensar. So it's unlike other artificial intelligence systems updated several months ago. We can keep
system,
up, but updated in real time as our client scenario evolves.
We are able to then collect documentation of both types.
PDFs, which are videos rather than links to repositories, elemental, ensuring our semantic type database gathers all this information and organize them within a single GeoDB.
Yes.
Why? Because we have brought into our large language model architecture the same logic of our digital twin architecture, where every object is absolutely georeferenced. And thanks to the integration of all this information and linguistic engines, extremely capable, we can indeed allow interaction between machines or between humans and machines through techniques from the most traditional chatbots or voice bots to the most advanced digital ones. Our system is designed with a workflow management perspective, and so the idea of interacting not just with humans like normal chatbots, but also with animals. With other digital systems, it's somewhat the foundation of our daily design of the evolution of this technology system. From the point of view both the architecture of our technology, we have right from the start I realized that the LLM model is one of the components necessary to understand a scenario. So we implemented our AI agent with this in mind. LLM technology that can be trained and improved upon to the basic models that can be either of like open source and also closed source. So our system interfaces with both. We have a vector database capable of creating local memory.
This vector database can be artificial intelligence integrated with information.
Actions coming from cloud and IoT. They can also be integrated with function calls to online APIs. So this is a very important topic. Because of the integration with the IoT, we can do it thanks to artificial intelligence that turns natural language into function calls. These data then also add up to each agent has a custom model file that somewhat describes the agent's personality, I can go to set up agents that
different
have
people
worked
collaborating with each other.
about
If not with
them.
one, this is the same.
On its own, AI can do
Agents
little.
among themselves.
It needs to interact to tackle complex issues.
We're working on some stuff.
Some use cases for some important clients, both sales approaches by our agents. So in a sales approach, there can be hanja saamasta customer. Here's the field. One of the areas we are working on is real estate. So we can have legal experts. Then I train to be legal experts.
And you've trained them to do property searches
on the market, properties that may have an economic advantage over others because they have characteristics which, from an arbitrage perspective, they have been identified. A benefit in purchasing one property over another.
Then I can have a building maintenance management expert who can to see the state of the building and understand the cost for its restoration and modernization according to the regulations. So this other agent can also be a beneficial one within the ecosystem of AI that deals with sales or of the real estate purchases.
Then the user will speak with a supervising agent who interacts with specialized agents trained specifically for this.
You were explaining something to me.
AI, a vector database that was built through the use of specialist documents, and these specialist documents together with custom model files describe in a special way what function does this agent have within.
About this mixture of experts, this mix of experts that then managed by the supervisor.
They discuss with the client to get the most out of the result achieved from a performance standpoint. There are also agents who deal with support. One of the real estate issues we are tackling is that of short-term rentals, for example. And in that case, when you have a customer who needs support, you have to turn to, let's say, to the expert on that specific need. So if I need an assistant who is a plant supervisor because I have problems in my home, I will speak with this person. If instead I want some tourist information regarding that area, because I've decided to do so, renting that apartment, and then however I want to go out for dinner rather than wanting to go to sleep, visiting museums around, I'll talk with Leia, who is an expert on the museum tourism and logistics to reach various points.
This is somewhat the approach.
What we are carrying forward,
we have
identification, the whole a quick and easy interaction tool for the user. So with our AI, our virtual assistant, certainly one can talk, interact, and ask for information. To reach it, to experience it, to live the tourist world around it.
It's obvious that in addition to
the whole digital twin team that provides support through the Internet of Things, it is implementable, and so we can combine the two worlds of support through our AI agents and those of the digital twin for the building safety rather than the building's energy management and the safety of the building and people, the viewpoint also of any potential situations that can arise inside the home. This is just a small introduction to this new part of technology that we have implemented in our laboratories. Currently, we have several ongoing projects that are covered by non-disclosure agreements, so we can't reveal them. It's a technology that has been available for about a year and a half. And the first customers started working there about a year ago. And so we're starting to see now the first interesting results of these solutions. Thanks everyone. If you need any information, feel free to contact me if you want to delve deeper. No problem at all. Thanks also to Wike for giving us this opportunity to make ourselves known and to let others know about us.
Our technologies.
Have a good day.
Hello, everyone.
Carry on.